Hello, sir.
Hello,
Yes, sir. You are audible right now.
I wasn't audible earlier.
No.
Okay,
No,
so
sir.
what I was asking is, what is y equal to mx?
Equation of a straight line.
Equation of a straight line which is passing through
Origin.
Passing through
origin.
origin.
Okay, so if I change the values of m here, so in general we know that this is a straight line. Okay, where m is an
Your
arbitrary
screen also isn't visible.
Sir, are you
screen.
sharing the screen, sir? Because
हाँ
it's not
सर
visible.
स्क्रीन नहीं है विजिबल
Yeah. just- Yes, now is it visible?
No, sir, it isn't.
Okay. So y equal to mx is actually a straight line, as someone said, and it is a straight line which passes through the origin. Okay. So in this case, m is an arbitrary constant. As you go on changing the values of m, what we'll get is we'll get different lines. All of them, those are passing through the origin. Okay, so whichever equation that you have with an arbitrary constant, this represents a family. Okay, and now what is my aim? I need another family of curves which cuts, which cuts or intersect, whichever word we can use, intersect the given family, the given family at 90 degrees. So what I am trying to think is I am trying to find out another family of curves which is going to intersect each and every member of this family y is equal to mx at 90 degrees. Can you think of any curve which will intersect each and every line at 90 degree here?
so circle with the radius as origin and at the center as origin
Yes, exactly. So if I draw a circle over here, so what I can see is this circle will intersect each and every line at 90 degrees. Okay. So in orthogonal trajectory, there are three terms involved. So first one is trajectory. I won't give you the definition of this trajectory in writing, but we'll just understand what do we mean by trajectory. Trajectory is the family of curves which intersects the given family according to some law. Okay, and the law may be the new family must intersect the given family at 60 degrees, say, or it must intersect the given family at 30 degrees. And the particular case of this is the orthogonal trajectory. Orthogonal trajectories. This is the particular case. So we find another family of curves which intersect the given family at with the angle 90 degrees. So this definition we will write it down here. So two families of curves are said to be orthogonal, are said to be orthogonal if every member of the either family cuts each member of other family, cuts each member of other family at right angle. So this is what we need to find. So one family will be given to us. I need to find another family which will intersect each and every member of this family at 90 degrees. So let's talk about the procedure first of all. So I have the equation y equal to mx. Okay. So if I differentiate that equation y equal to mx, so I have this y equal to mx, then I'll differentiate this dy by dx is equal to m. I'll put that here. So we get y is equal to dy by dx into x. What is this? What is this? What is this called? Y is equal to dy by dx into x. You have done this. Yes, be quick. Am I audible?
Yes, sir.
Uh-huh. So when you differentiate as many times as the arbitrary constants are there and you eliminate the arbitrary constant, what do you get?
Linear differential equation.
Differential equation.
So differential equation of the given family. Yes. So now in this, what will this dy by dx represent? What is
So
this?
slope of the slope.
This is the slope of the curve at any point x comma y. Okay. So slope of the tangent actually. So whatever curve is given, if I find out dy by dx, then it will represent the slope of tangent to the curve at the point xy. What do we need? Say this is the line. I'll consider one line. Say I'll call this L1. Okay, L1. I need another curve. Okay, so this is my curve. So I need another curve which will cut this curve at 90 degree. So what will be the angle between these two? That is 90 degree. What is the relation between the slopes when curves intersect?
Product of the slopes is -1.
-1. So given family y is equal to mx, I found the differential equation of it. So we got y is equal to dy by dx into x. In this, we know that dy by dx represents the slope of tangent to the given curve at the point x comma y. This is what dy by dx represents. Now, this is my curve. I need another curve. As guessed earlier, it is a circle. And if I draw tangent at this point, then the angle is 90 degree. As someone said, dy by dx. So whatever is the tangent, say I'll consider it m. I need the angle between them to be 90 degrees. So this has to be -1. So the required orthogonal trajectory must have the slope m is equal to minus dx by dy. Am I clear up to this? So I have the slope of the given curve. I need the slope of the tangent of its orthogonal trajectory. What is the relation? Both the tangents are going to be perpendicular to each other. And that's why the slope of the required orthogonal trajectory has to be minus dx by dy. So replace dy by dx by minus dx by dy. Q, because orthogonal trajectory को जो tangent होगी, that is going to be perpendicular to this. And we have seen in our 12th standard or the 11th standard that if two lines are perpendicular to each other, then m1 into m2 is equal to -1. So by that relation, the required family of curves must have its tangent's slope as minus dx by dy. So what do we get here? Y is equal to minus dx by dy into x. Let's get it into variable separable form and integrate. So y dy plus x dx equal to 0. If you integrate, what is the answer that you get? So this will give
Equation
me
of circle.
x square plus y square is equal to c square. So we have proved mathematically that orthogonal trajectories of the straight line is actually the circle. Okay. So this is the complete procedure now. So let's repeat the procedure. First of all, given family, what I need to do is I need to make a differential equation out of it. Once you get the differential equation out of it, replace dy by dx by minus dx by dy and then solve. Okay. So I hope it is clear to you. I'll go for examples now. Example. Find the orthogonal trajectories. Find the orthogonal trajectories of x square plus 2y square equal to c square. What is this? What is this? X square plus 2y square equal to c square.
Equation of circles.
Is it circle? Are you sure?
No.
No, it's not circle.
What
No,
is
sir,
it?
it's not a circle.
It's a,
Can be ellipse.
it's an ellipse. Yes.
It's an ellipse.
Yes, sir.
Yes. So let's differentiate it. Let's go with our procedure. How many arbitrary constants? 1. So differentiating with respect to x. What do we get? 2x plus
0.
2y, actually 4y, sorry, 4y dy by dx equal to 0, which I can write as x plus y dy by dx equal to 0. Look, arbitrary constant is eliminated, so this is the differential equation of,
टू y होगा ना?
Sir, हाँ 2y होगा.
Sir, it will be 2y, right?
yes, 2y dy by dx. So this is the differential equation of given family. So our required family is perpendicular to this, okay? And to find that, what we do is we replace dy by dx by minus of dx by dy. So what do we get? X minus 2y dx by dy equal to 0. Let's get it into variable separable form. So we will have x is equal to 2y dx by dy. So dx upon x on this side, this will be equal to dy upon y. Please check the calculations. Now this is variable separable form. So we'll integrate. So let 2 log x is equal to log y plus, for simplification, I will write it down log c. So what we'll get? X square is equal to c into y.
Sir, why, sir, if two variables are in log form, then we also write constant with log.
I didn't understood what you said.
Sir, in this equation, sir, log x equal to log y, and we write a constant. So in this case, you write log c. So the region, sir, is
I wanted to simplify it further. C I can write as c, okay, but c is log of some other number, right? So it doesn't matter whether I write c or I write down log c.
okay, sir. Yes,
है ना?
yes, sir. It will become a constant further.
Anyhow, it is a constant.
Okay.
X square is equal to cy. What is this?
Parabola.
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 So for straight lines, orthogonal trajectory is a circle. For ellipse, orthogonal trajectory is parabola. So I want you to find out the orthogonal trajectories of another family of curves, and that is xy is equal to c. Find orthogonal trajectories of xy equal to c. Try to find it out. What do you get? So by the time I write down the method here, first is form differential equation. Form the differential equation of given family.
So y square is equal to x square plus c
Y square
is equal to x square plus c.
yes. So can you tell me what is it? is correct
So
actually.
it will be circle only, I guess.
No.
No.
Hyperbola.
I don't know, sir. Yeah, hyperbola.
So it is a hyperbola. When what is the given thing? Xy equal to c. What is it?
Rectangle hyperbola.
Rectangular hyperbola. Okay. So for hyperbola, orthogonal trajectory you have got is hyperbola. I can say that, right? So if you have some family of curves and its orthogonal trajectories are itself, and in that case, what do we say is that family is self-orthogonal. Okay. So I will just write down a note over here. I have written the method. If you want, you can note it down somewhere. And this is a note, which is a very important thing. If this can be there in some MCQ, if after replacing dy by dx by minus of dx by dy, we get same equation. Same equation, then given family is self orthogonal. Okay. So if you want an example, I'll give you this as a homework. You can try this later, and you can see that after eliminating arbitrary constant and you replace dy by dx by minus of dx by dy, for this a particular example, you will get the same equation, and this is self-orthogonal. Okay. Can anyone tell me something about polar coordinates? What is
So
what
they
are
are in the form of r comma theta.
they are in the form of r and theta? Exactly. What does the r represent?
Under root x square plus y square, where
Graph,
x
graphically,
R represent distance from origin.
distance from origin,
Shortest distance.
origin, and theta,
So the angle
Inclination
subtended
from positive x-axis.
inclination from origin
angle
Inclination.
with
or
positive x-axis.
inclination from
Positive
x-axis.
x-axis.
Positive
Point
x-axis.
or origin. Yes, sir.
Okay. So every point in a plane can be given by r and theta, and in this case, r is the distance from the origin, and theta is the angle made by the position vector with positive direction of x-axis. So this is another nomenclature, or what we can say, another way of giving names to each and every point in a plane. Okay. So these using r and theta, we also can get equations. Say if I write down r equal to 2, can someone tell me what is it? Can you collect all the points in a plane as you said, distance r is nothing but distance from origin. Can you collect all the points
It can be a
which
circle.
will have distance of from the origin as 2?
Circle.
What you will get graphically?
Form a circle.
You will get a circle, exactly. So this is nothing but a circle. Okay. So in polar coordinates, this is circle. Also, if I get r square is equal to a square cos of 2 theta, say. Again, this is something that you'll see in the second module, and what we get is a p orbital like structure for this equation. Okay. So polar equations can also have orthogonal trajectories, as you can see here. So in that case, the only difference is in Cartesian you replace dy by dx by minus dx by dy. In polar, replace dr by d theta by minus r square d theta by dr. Just remember this, we won't go into details of the proof. So if we have a polar equation, then dr by d theta needs to be replaced by minus r square d theta by dr. Very important point. Example. We'll see. I mean, don't get into confusion ki how did I draw this curve. In the second module, we'll see how to draw these kind of curve. R square is equal to a square cos 2 theta. We'll also draw r is equal to a cos of 2 theta. So let me tell you, it looks like this. Okay. So I just want to make you understand that polar equation also will get. I mean, those will look like r is equal to f of theta. Okay. So these kind of equations are called the polar equations, which I will differentiate dr by d theta. I'll get something f dash of theta on the right hand side. Then I will replace this dr by d theta by minus r square d theta by dr. This is f dash of theta. And then we'll solve this. So this is how we get the orthogonal trajectories for the polar curve. Example. Find orthogonal trajectory for r is equal to a cos theta, where a is arbitrary constant. So what is the procedure? Differentiate with respect to theta. So what will get dr by d theta is equal to minus of a sin theta. If we need to form the differential equation, I'll put this value from this. I'll get a is equal to minus 1 upon sin theta dr by d theta. You substitute this here. So what we get? R is equal to minus of cot theta dr by d theta. Please check the calculations. Now this is the differential equation, okay, of given family of curves. Now we will replace dr by d theta by minus r square d theta by dr. So what we'll get? R is equal to r square cot theta d theta by dr. Again, one of the r will get cancelled out. 1 upon cot theta will become tan theta upon d theta is equal to
Sir,
r
how you
upon.
got that cot theta?
When you put this value of a in this equation, what you are going to get is r is equal to
Okay, sir.
minus 1 upon sine theta dr by d theta into cos theta. So combining these two, I got cot theta over here. Now we take the reciprocals. Again, I have done some mistake over here. So 1 upon cot theta d theta wasn't taken. So when you take the reciprocal of this, 1 upon so you'll get dr upon r is equal to cot theta d theta. This is variable separable form integrating. So you'll get log r is equal to log of sine theta plus log of c. Again, I can simplify this, and what I will get is r is equal to c times sine theta. Clear?
Yes, sir.
Try to solve one. R square is equal to a sine theta. Find orthogonal trajectory of r square is equal to a sine 2 theta. Let's do it quick.